Hello everybody! Welcome! Welcome to this video series. I've been meaning to do this video series for about 6 months now, and I'm finally getting around to doing it, so it's so great to be here with you today. This is the first part of a multi-part series about me fixing up my application, which is called PHP Monitor. Now, I consider PHP Monitor to be a competent, modern macOS application, as in, if you run it and you've never seen the source code, it is pretty great, right? I love using it myself. I think I've done a pretty decent job at making it, but unfortunately, it kind of sucks. The code behind it kind of sucks. And maybe you've gone to the GitHub repo and you've checked out some of my code and you think, that's not too bad, I've seen better stuff, but this isn't too bad. And then, maybe you're right. I don't know. But I do know that I have a bunch of issues with my code. And I want to talk about that today because, self-reflection is useful, but also it is also helpful if you can demo stuff that doesn't work and then fix it. It's one of the most beautiful things you can find on the internet, right? Is videos on people showing you where you went wrong and then how you can fix that. It's great. And so it also works with coding videos. I really enjoy watching video tutorials. Is not a thing that I would generally say. The truth is, I don't watch a lot of video tutorials because I find most of them at this point in my coding career pretty cumbersome and just boring, flat out boring. But what is interesting is when people look at their code and evaluate it and then go, oh, well, this kind of could be done in a different way. This could be better. When there's kind of a self-reflection or a correction or a refactoring going on, I think those are the most interesting videos because they explain how we thought about problems initially and how our thinking about certain problems has changed, or maybe things we've learned. And so that's the point of the video series here. It's in part of course, that video series that I was talking about earlier where I basically explain how the app works, but also how it is constantly evolving. I've been wrestling with when am I going to record this thing? And the big issue has always been, I don't know. And the truth is, the I don't know became, I'm going to do it at some point, right? And now here we are. Things are constantly in flux. I'm refactoring a bunch of stuff as we speak in the app. We're at version 5.4 right now. That is what we'll be releasing later this month with big changes. So let's talk about that, right? I'm making big changes. Why am I making big changes? Well, because my code sucks, okay? Now, why does it suck? Why is my code bad, right? Why should I feel bad about it? Well, there's a bunch of issues. So I actually made this slide deck, or these slides, a while ago. I've now made some changes, corrected them. But let me show you what the slide originally looked like a few months ago. It looked like this. Our first item was there's not enough tests, right? The most important stuff is tested, like all of the functionality that I wouldn't want to go and manually test every time. It is tested, right? Most of this stuff is unit tests as well, so it's great. Then, second question, or second issue is like, there's some places where optimization is certainly possible. I know that there's a bunch of places where things are running fine, but there is clearly a more optimal code path where, less work could be done if certain caching is implemented and stuff like that. So optimization, right? Then there was the clunky code, the /inconsistent code style problem. There was no linter in my code. This is a thing that's been remedied, right? At this point, there is SwiftLint is being used, and I have fixed all of the style issues. But this is the biggest issue. There are, to this day, many singletons and interlinked dependencies, and interlinked dependencies within the classes, so classes linking to each other, not like third-party dependencies, that make testing difficult, and I'll be talking about that in a bit. And then, of course, the app is still using storyboards, which is kind of legacy at this point. We have SwiftUI nowadays. If you've been following me for last week, you know that I'm working on some SwiftUI stuff. So this one as well has been outdated. So we can say, okay, clunky code, linting, that's been fixed. And we're moving towards SwiftUI adoption, so that's good. But we're still dealing with storyboards as we speak, so it's kind of an issue. All right, so the way I see this going is for the next few months, I'll be working on 3 major transitions within the code of the PHP Monitor application, right? So 3 transitions. The first one is to remove spaghetti code. Why is this relevant? So when I first started working on this in 2019, it was a hacky app, okay? That's just the truth. It was very hacky. It was something I made for myself, right? It wasn't a big project. There wasn't, hundreds of people using the app. So I was fine shipping something glitchy or something very simple. And, all it was at the time was a simple drop-down menu with 4 items. So there wasn't really that much going on. Since then, the app has grown in scope significantly, and there's a bunch of stuff that is just like hard-linked that I consider spaghetti code that needs to be fixed. We have a bunch of God objects, we have a bunch of singletons, like it's all things that need to be fixed. The second item is moving away from storyboards to SwiftUI. It was this year at WWDC, so 2022, when Apple basically said it's the best way to make apps going forward. And this is something that they didn't want to say before, but now they have said. So, it's time to move on past storyboards. Storyboards are a pain in the ass anyway, so it's a good thing we can transition away from them towards something a little bit more modern. SwiftUI certainly isn't perfect, and there's plenty of issues still with adopting that. But I think it is generally, at this point, probably superior to storyboards in almost every way. And then finally, not super recently, with the last few versions of Swift, introduced async await. When I first started building the app, this wasn't in, so everything that needed to happen asynchronously used dispatch queue. So in iOS and in macOS, you can basically dispatch a particular workload to a different queue, and you had to do that manually. You had to manually say, hey, I want to dispatch to, asynchronously to a different queue with this priority, and then you would put a block of code and a callback as well. So you would have escaping blocks that would contain the logic. So you would get effectively the equivalent of callback hell in Swift as well if you didn't pay attention to what you were doing. So these 3 things I intend to remedy. And that's it. So in the first video after this, we're gonna dig into that first item here, which is, or actually in all 3 of them, but let's cover them all in sequence. So the first one is gonna be what's going on with the spaghetti code. So let's go.